All right, so I wanted to walk through the process of completing the Kid Brother periodic table project or assignment. And I have the periodic table here, the blank version that's with the assignment. I went ahead and added some of the key elements, sorry, no pun intended, uh, in terms of valence electrons, ion charges, the different classes of elements, and the rows, which are the electron shells. So that will hopefully help see why I'm putting things where I'm putting them. And then at the end, I'll show you the completed kind of clean version so you have that answer key available. But I also wanted to give you the explanation as I go. So looking at the first clue, TR, GX, BRB all have 2 electron shells. So that means 2 electron shells means they're in the second row. So we have T, I'm just putting them in the order they appear. These are not necessarily the order they're going to be in at the end. GX and B and RB. Okay, 1, 2, 3, 4, 5 all have 2 electron shells. GX has a radius between R and I. Okay, I don't have I on here yet, but I have R and I have GX. So for right now, I'm going to leave that as is because all I know is it goes in between 2 other elements and I don't know where the other element is yet. So I'm not going to make any other changes, but those are all in the correct row based on this, this first clue here. Rb, which is one of the elements we just placed, is a noble gas. So the noble gases are over here in the group 18, which I have colored in the sort of pink. So if it has 2 electron shells and it's a noble gas, that means it belongs there. And I know now that that is definitely where that goes. So I'm going to go ahead and mark that in green so I know that that's locked in place. That's definitely where it goes. I don't have to move it anymore. Number 3 says element I is a halogen. Okay, halogens are in group 17 with 2 electron shells. So we're in that same row still. We're still in the second row, but now we have element I. Group 17 is the halogens, and it has 2 electron shells, so there's no other place that can go. So that one clue gave us the exact spot that that element I has to go. So now I have, from the earlier one, I have R, GX, and I. So GX has to be somewhere between R and I, but we don't know exactly where yet. But I know it can't be in group 18 because it has to be between I and R. So that means GX and R are going to be to the left of I somewhere. We'll have to figure that out as we go down the list here. Okay, the alkaline earth metals, that's group number 2 on the slide here. It's in yellow, are K, U, B, YO, KC, and AK. So we actually already have B here. We know B is in group 2. So I'm going to move these 2 over. And I'm going to put B there because we know it's in the second row from the first clue. And now we're being told that it's an alkaline earth metal, which is in group 2. So row 2 and group 2. That element is now locked in right there because in order to have 2 electron shells and be an alkaline earth metal, there's nowhere else it can go. All right, so then the other elements that we have to get in here are K, and I'm just putting these in the order that they're listed so far. U, B, which we have, YO, KC, and AK. Okay, so those I know are in that column because they're alkaline earth metals, but other than B so far, I don't know the order that they're going to go in exactly. Okay, so that takes care of that clue. AK, okay, which is one of the ones we just placed, has 6 electron shells. So the electron shells are the rows. So that means that AK goes in row 6, and I'm just going to switch those around for now. I don't know if that's where KC actually belongs, but I do now know that is exactly where AK belongs, because it's an alkaline earth metal with 6 electron shells, 6 energy levels, so there's nowhere else that AK can be. We've narrowed it down by group and by row. Okay, so that takes care of that. YO, which is one of the alkaline earth metals we have here. This is one of the clues. There's a couple of these where it kind of gives you hints about what the elements are in terms of how they're used. So this says it burns brightly and can be found in an antacid medicine in the form of the element and then hydroxide. So you'd have to either look this up or be familiar with these properties, but that is actually the element magnesium, as in milk of magnesia, which is also a metal that burns. And it makes a very, very bright white light, and actually a lot of ultraviolet light when it burns. So once you figure out that that's magnesium, that is where it belongs. That's the spot that magnesium appears on the periodic table. Okay, so that takes care of that one. M tends to lose 3 electrons and has the smallest, second smallest atomic mass in its group. Okay, so if it loses electrons, this is where you have to think about what that means. Losing electrons means you end up with a positive ion. It's tricky, but it's true, because you're losing the negative charge, so the balance tips in favor of positive. So an atom that loses 3 electrons is going to form a positive ion, positive 3, which I have here, right? Positive 3. So it's going to be in this column. And it says that is the second smallest atomic mass. So the atomic mass gets bigger as you go down, or smaller as you go up. So the smallest mass would be on the top. Second smallest would be in the second spot in that column. Okay, so a +3 ion at the second smallest in its group, that's the only place that that element could be. V is the most metallic. Metallic character gets bigger as you go down into the left. So the most metallic element would be the one in the bottom left-hand corner. And just all I need is that one characteristic to know the most metallic is the one in the bottom left. So there's nowhere else for that to be, because as soon as you move out of that spot, you're getting less metallic. All right, now we have a whole list here. D, B, Y, N, O, K, E, Y, X, L, O, and P are all in the same row. And it says that EY has the lowest ionization energy and DB has the largest. And then, probably the most important thing on this list is that they all have 5 electron shells. So that means 5th row. All right. And it says EY has the lowest ionization energy in the 5th row. Ionization energy increases from left to right. So the highest is on the right, the lowest is on the left. So EY has the lowest ionization energy in its row, which is the 5th row. So it has to go in the very first column in the 5th row, because that's the lowest ionization energy. On the other side, it says DB, that's the right one, right? Yes, DB, 5th row, highest ionization energy would be on the right-hand side. Okay, so now we have the ends of the row, and we know K, actually, we know it's an alkaline earth metal from an earlier clue, and now that we know it's in the 5th row, we can lock that one down. So those 3 are fixed. And then we have we have Y, we have NO, we have XL, O, and P. That's the one that's not there yet. Okay, so we know that those are in the 5th row. We don't yet know what order they're going to be in. So I'm not going to lock them in place yet, but we have taken care of that clue. All right, and now we have another list, D, O, Y, W, E, C, D, and E. and O are all metalloids. So the metalloids are these gray ones here. We know that O is also in the fifth row and Y is in the fifth row. So if Y and O are metalloids in the fifth row, they're going to be in those two spots. I'm not sure if that's actually, if they might need to be flipped around, but they're definitely going to be in those two spots. So then let's see the other elements. We have DO. And I'm going to fill in the metalloids just in the order they're listed. WE. These are not necessarily the right spots yet. C, D, E, and then I already have O and Y. Okay, so those elements are going to be in those gray boxes. I just don't know yet exactly where. And then it says Y is in GX's group. Well, for right now, since I don't know actually which group GX is in, I'm going to leave Y right where it is. And then if GX moves, we'll have to move Y, and that means we'd flip Y and O. F, U, A, so hold on. I actually haven't finished that clue, so I'm not going to cross it off yet because I need to keep in mind that the Y and GX relationship. F, U, A, and L are all alkali metals. So there's three alkali metal boxes left. Because remember, even though the top box on this column is in the alkali metal group, that's hydrogen, which is not an alkali metal. U and L, okay, are going to be in those three boxes. I just don't know what order yet, but I know they're going to be in that column. So that covers that one. P is a brown liquid that's put on cuts to disinfect them. If you are a Peanuts fan, you know that when you get kissed by a dog, you need disinfectant, you need iodine. Iodine is the element, it's a halogen, okay, fluorine, chlorine, bromine, iodine, astatine, those are the halogens. So halogens are the green boxes, and we already know that P goes in the fifth row. So the halogen in the fifth row, which is iodine, I now know that that's locked in. Okay, R is in group 15. Okay, so now if R is in group 15, then GX has to be in group 16 because we learned earlier on that GX was between I and R. So it says R is in group 15, and we earlier knew that it was in row 2. So row 2, group 15, that's that box right there. There's nowhere else for R to go. And if GX is between R and I, and we know it's in the second row, there's nowhere else it can go. Now I'm going to go back because we have that clue that said Y and GX are in the same group. So that tells me that those two elements need to trade places. But it also tells me that Y has to be in that box because it's in the fifth row, it's a metalloid, and it's in the same group as GX. So group 16, row 5 has to be there, which is also a metalloid. So those three clues combined make me absolutely sure that's where Y has to be. Which also means if O is a metalloid in the fifth row, it has to be here. Just combining those two clues from earlier, there's no other place where a metalloid in the fifth row could go. So that one is now locked in. So that also took care of the last bit of this clue that I hadn't filled in yet. Q is a halogen, which is group 17, directly under I. So we have I, now we have Q directly under it. Nowhere else for a halogen directly under I to be. J has an atomic mass between DB and BY. Okay, I don't know where BY is yet, so I can't really place J because it could be, it could be either above or below dy. So we're going to hold on to that. There's BY. BY is the most massive noble gas. Okay, so noble gases are in the pink boxes. The heaviest element is always the bottom of the column. The bottom row of the periodic table is the heaviest. So By, being a noble gas and being the biggest one, has to be the bottom box in that column. Okay, so that's done. And now I can actually go back because I was told that J has to be in between DB and By. So it's got to be in between. Okay, so that's where that's going to go. And I can cross that off. So the next clue says in order of decreasing ionization energy. Decreasing energy. Ionization energy increases from left to right, which means it decreases from right to left. So these elements are going to be listed in order from right to left across a row or down a column, but it does tell us at the end here that they have 7 electron shells, which means the 7th row. So they're giving us the 7th row elements in order from right to left, which is decreasing ionization energy, excluding groups 1 and 18. We already have 1 and 18 locked in with B and By, so that's fine. And it means I'm going to start with group 17, have being Me, then Lb. Again, they told us this is just in order in the 7th row of decreasing energy, which is right to left. Then BB and JF and RH and U. And I already have an element here, but that's because I wasn't sure which order the alkaline earth metals were going to go in, or at least some of them. So if I trade around, now I have U, which is the last element in that list. So that's definite. And since there's nowhere else, we know Kc is an alkaline earth metal, all the other spots are locked in. I can now say for sure that Kc is locked in that spot. We've got that one done. In order of decreasing atomic radii, so atomic radii decrease from left to right. So this is giving us a list from left to right, and it says excluding noble gases are A followed by Kc. Well, I just established that Kc went there, so that means that A must be in the same row. So I can lock that in place. Kc, N, Do. I have an element here, but Do is a metalloid. We knew that much, but we didn't know where it went. Now we know it's going to go in this row as a metalloid. And then the next one is D, which actually is already there. We knew it was a metalloid. We just didn't know which row. Now we know which row it goes in. NH and UN. Okay, and there's a blank spot at the end of the row, and you might say, well, how do I know that none of those shift over? Because it does say excluding the noble gas. So it was telling me that I wasn't going to get to the noble gases, which means if I have 7 elements in order, it's groups 1 through 17, decreasing radii going left to right. That's the only order they can fit because we were told not to include the noble gases on that list. So that takes care of that. Group 15 has elements with increasing atomic radii. Increasing is going down. Okay, so the biggest elements are at the bottom in terms of radius, the smallest at the top. In group 15, or R, which we have, HN, so that is locked in place. And then DO, which we already had, we already knew those were there, it's just confirming that. And then X, group 15. And we have BB, hopefully it says that. Yes, BD. So that, there's some of those that we already had locked in place, but that's, again, one more piece of evidence that that's where they belong. We just had the couple blanks to fill in, and it gave us the order they go in. Animals require the gas GX to breathe. Well, that would be oxygen. So GX should be in the spot where oxygen is. Oxygen's the top of group 16, so it's already there. But again, just giving us more information to confirm that that's where it belongs. F is in the alkali metal group, but it's a gas at room temperature. There's one exception to the alkali metal group, and that's hydrogen. So the only place where F could be is in the spot for hydrogen. It's an alkali metal group in the alkali metal group, but it is a gas. It's the only exception to that rule. And then the next one says Fu, which we know is an alkali metal from an earlier clue, has a configuration that is 6s1. Well, 6s First of all, the 6 tells us it's in the 6th row. So an alkali metal in the 6th row, there's only one place that could mean, because now we have the row and the column. Group 1, row 6, can't be anywhere else. And all the elements in the first column end with a configuration of S1. So the 6 just told us which row it was going to go in. All right, T is the second smallest alkali metal. And what this, I think I updated this in the worksheet. It should say the second smallest in the alkali metal group, because the second smallest alkali metal would be in the 3rd row, because the first one technically isn't an alkali metal. So it's the second smallest in the alkali metal group. Well, the smallest is hydrogen. The next smallest would be lithium. So that's there. And it says B's atomic radii is slightly greater than C. Okay, so we've got B, and then C would be the next one. So that tells us it goes to the right, because the radius gets smaller as you go to the right. And C is slightly greater than S, which means S is to the right of C. So now we have that whole row filled in and locked in. There's nowhere else for those to go. And they have 2 electron clouds. That was the last point of that, which meant we knew they all had to be in the 2nd row. All right. Group 14, ionization energies decrease in order. Decreasing ionization energy is going down. So we have S, which we already have at the top of group 14. WE, we knew it was a metalloid. We didn't know what group or row it was in until now. We're being told it's in group 14, so that locks in. DO, we have NO, which we weren't 100% sure about. We knew it was in the 5th row, but now we know it's 5th row, group 14. That zeroes in on that spot. W, which we don't even have on the table yet. That's group 14. And then JF, which we already had. We knew it was in the 7th row. And that just confirms that it belongs in group 14, which we knew because we were given the order in an earlier clue. WE is used in computer chips and has 3 electron shells. All right, computer chips, silicon. Silicon's the 2nd element in group 14. It's also a metalloid. It's also in the 3rd row. So all of those things we already knew. But the 3rd, that just, again, confirms that that's in the right spot and should not need to go anywhere else. Okay, U is the largest alkaline earth metal. We have that in place already. But again, these are all just confirming the process. L has a larger radius than T, but smaller than A. Okay, so T, L, and A are all in the first group, and the radius gets bigger as you go down. So it says it's bigger than T, but smaller than A, which means it has to be in between those 2. Okay, we're getting pretty close to being all locked up here. In fact, XL we can lock in because we know it's in the 5th row and there's no other places available. So process of elimination, it has to be there. Z is a noble gas. There's a couple of spots in the noble gases left, but it has 2 valence electrons. That's a special exception to the noble gas group. That's helium. Every element in the noble gases except helium has 8 valence electrons. So the only one that doesn't have 8 is helium because it only has 2. Okay, K. Element K is directly below Kc. Okay, we have that already. XL has a greater electronegativity than G. We don't have G on here yet. So the fact that XL's electronegativity is greater than G means either it's above G or it's to the right of G, because that's the trend. Electronegativity gets bigger going up and to the right. Well, there really isn't anything to the right of XL. So in order for G to have a lower electronegativity, it means it needs to be below XL. So that gives us that. H is a yellow powder in the same group as GX. Well, the only spot available in the group with GX is that spot right there in the 3rd row, because E we know is a metalloid, so it has to be in that spot. And if you look at that spot on the periodic table, that is the element sulfur, which is a crumbly yellow solid in the same group as oxygen. Kc loses 2 electrons to become like EF. Okay, so if Kc loses 2 electrons, that means the number of electrons goes down by 2. So it would go from, that would be element number 20 normally. So if it loses 2 electrons, it goes down to element number 18, which would be a noble gas. So if it's saying that EF is the element 2 below Kc, then that has to be right there. And it says that EF is unreactive, which makes it a noble gas. So we only have a couple spots left. We need to figure out where they go. Bn has a full valence shell, which means it's a noble gas. And it also says it's in the 4th row. The only place that's left in the 4th row is right there in the noble gas group. So that tracks, it's true in both points. It's full valence shell, 4th row, noble gas in the 4th row. And then finally, Y has a configuration that ends in 5p4. Okay, so 5p4 means 5th row, the P block, which starts with group 13, and the P4 means it's the 4th one in the P block. So XL would be P1, NO is P2, O is P3, Y is P4. We have that locked in place. And then the last clue, the last element, says that E and LM are in the same row. And it says that E has the smaller radius between those 2 elements. Okay, so actually E needs to move over here. This is a tricky one because the halogens and the metalloids intersect, so I couldn't do both colors. I apologize about that. But E is the smaller radius. Radius decreases from left to right. So that's why we couldn't lock this in place yet, because we didn't know for sure. Okay, so that's the finished product. All the elements we filled in with the clues. We locked them in place once we knew they couldn't be anywhere else. So just to show you the sort of clean version, that's what it should look like with all the elements in place and not all the messy coloring and all that stuff, which I think helps when you're putting them in place, but it doesn't make it look great at the end. So that's the straight shot right there. I also posted a picture of this as an image for you as well. All right, that's how we do that.